exercise. Suppose there is a cuboid structure of 12 wires of equal length. Now we have to find the EMF. Number one case, when the cuboid move parallel to B. Number two, when cuboid moves parallel perpendicular to B. First is, so this is the cuboid A, B, C, D, E, F, G, H. There are 12, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 wires are there. They are equal length. And first case, it is moving in the direction of magnetic field is this side from left to right, and the cuboid is also moving in this direction. So what will be the direction of EMF? Now EMF can be given as by the vector notation. EMF is equal to given by the scalar triple product. It is given by scalar triple product. So EMF is equal to V cross B dot L. V is the velocity, B is the magnetic field, and L is the length. So this will be a scalar triple product. Now in a scalar triple product, if we have the same order, then we can change dot by cross. So this is also equivalent to V dot B cross L. Order is same. This is also equal to B dot A cross B. So you can change the order. You cannot change the order, but you can change the cross product by dot product. So in the first case, when the cuboid is moving in the direction of B, then V and B are in the same direction. So V cross B will be equal to 0. In this case, V cross B will be equal to 0. So V and B are parallel. So V cross B is equal to 0. So EMF will be equal to 0. V cross B is equal to 0. Therefore EMF will be 0. So if the cuboid structure is moving, its velocity and B are in the same direction, then there will be no EMF, there will be no induced EMF produced, and EMF will be equal to 0. In the second case, when cuboid is moving perpendicular, this is the direction of B, and it is moving perpendicular to the direction of B. Now, then we have to consider different sides. If we consider AE, then BF, then CG and DH. All these directions, all these lengths are parallel to V. All are parallel to V. So when L and V are parallel, then this cross product will be equal to 0. So in this case, for this and this, all the fours, the EMF will be equal to 0. Because V is parallel to L. Now we consider AB, BC, EF and HF. These all the sides are parallel to B. These all sides are parallel to B. L is parallel to B. So when L is parallel to B, then L cross V will be equal to 0. So in this case also EMF will be equal to 0. So there will be no EMF. Now we case the third case where AD. This is AD. This is AD. BC, EH and FG. These four sides are perpendicular to V and B both. V is in this direction. So it is perpendicular to B and it is perpendicular to A. So in this case, for this AD, BC, EF and FG, B and V both are perpendicular to L. So when they are perpendicular to L, what will be the EMF? EMF will be there and EMF will be equal to कितना हो जाएगा? It will equal to B into V into L as we have calculated earlier. So the EMF will be produced only for the sides which are perpendicular to V and B both. If they are parallel to B, then EMF will be 0. If it is parallel to V, then it is 0. So only these four sides, if AD, BC, FC and EH, they are perpendicular to both V and B, so EMF will be generated. So only for these four sides, EMF will be there and the value of EMF will be equal to BV into L as we have calculated earlier. Now second exercise, suppose we are having a metallic disc. Suppose this is a metallic disc and metallic disc is rotating with the angular velocity omega and it is placed perpendicular, its plane is perpendicular to the magnetic field. So here we have considered the magnetic field is inside it. It is perpendicular to the disc. This is the complete disc. This is a disc, metal disc, and its plane is perpendicular. So magnetic field is perpendicular to this. And this is the hinge. And above it, it is moving, it is rotating with the angular velocity omega. So how we can solve it? We can consider that disc as a number of wires, large number of wires. They are of equal length because their length is equal to the radius. And we are so this is the center about which it is rotating. This is the end of this. Suppose this is O point, this is point A point, this point O point, and this point is A point, and it is rotating with the L. Then we have calculated for this the EMF, induced EMF will be equal to B omega R square by 2. This will be there. So for this it will be there. And we can write omega is equal to 2 pi F into R square. 2 cancel. So B into pi R square into F. And pi R square is equal to A. So EMF is equal to BAF for any one length. Now there are all the lengths are there. So the EMF will be equal for all these lengths. Now what will be the total EMF? So here we consider that this point is center point will be positive. So this point is positive. And this point will be all will be negative. So all positives are connected here. All negatives are connected. Their EMF of this side, and all go to infinity. Then the total EMF will be equal to say. So the EMF of this which is rotating with the angular velocity omega whose radius is r, it will be equal to B omega R square by 2, or it is equal to BA into F. F is the frequency of rotation, number of rotation per second. So in this way, we can consider the disk as number of the length wire L, whose length is R, and they are rotating, so the EMF produced between the center will be always positive, it will be always negative. All the positive are connected at the same point, so all these points are connected positive here, all the negative are connected here, so their EMF are equal, so total EMF will be equal to the EMF of one wire. So the EMF will be equal to E will be equal to BA into F or B omega square, omega R square by 2. You can have any one value of this. Now next exercise is, if we are having a capacitor whose plates are A and B and they are connected by a wire, and we are having a magnet and we are magnetic moving towards the condenser C, then what will be the charge on A and B? We have to find it. So now when the magnet is moving towards it, it means what will happen? The magnetic flux will change. Then according to the Faraday's law, when there is a change in magnetic flux, then there will be induced EMF will be produced. So induced EMF will be produced. Now the direction of induced current will be given by the Lenz's law. Lenz's law says that the induced direction of induced current will be in such a way that it will oppose the cause which has produced it. So N is going towards N. So this way will be, if you see from magnet side, it is our eye, and we are looking from the magnet side, then this will be N side. So when N is there, then it will be anti-clockwise. This is N. So N will be repelled by N. So it will be anti-clockwise. So current will flow this. So A will be positive and B plate will be negative. So the question is, when there is a capacitor, it is connected by wire here, and we are having a magnet, and N pole is going towards it. Then due to the change of magnetic flux, induced EMF will be produced and induced current will be flowing. The direction of induced EMF, direction of induced current will be given by Lenz's law, and it will be anti-clockwise. If suppose it is in different direction, suppose if it is moving from away from this, then it will be a S side. So here it will be clockwise. Then this plate will be positive and this plate will be negative according to the Lenz's law. So we have to apply both the Lenz's law as well as the Faraday's law. Due to the change in magnetic flux, induced current will be produced. The induced current will be such that it will oppose it. So if it is N, the S will be produced. When S is there, then current will be clockwise. So it will be clockwise. So it will be positive and it will be negative. We have to find the induced EMF and induced current when a rectangular frame or rectangular coil is rotating in the magnetic field. So we have to find the induced EMF, induced current when a rectangular frame is A, B, C, D. Here there is a north pole and south pole. So direction of B will be from north to south. So this is the direction of B and it is the frame here. At any instant, this is the position of ABCD. then this is the direction of P, and we have a normal to the area, then area vector will be in this direction. So the angle between area vector and the magnetic field is equal to theta. So direction of area vector will be perpendicular or normal to the area. Area is a scalar quantity, but area vector is a vector quantity. Its direction is given by the perpendicular to the plane. So this is the direction of A at any instant, and theta is the angle between B and D. So what will be the magnetic flux? The magnetic flux will be equal to phi B will be equal to B dot A. B is the magnetic field, A is the area vector. So it will be equal to B A cos theta. Now, what will be the angle there? It is, we have this is the axis, and axis is rotating by angular velocity omega. So at any time angle is theta, means the angle theta is equal to omega into t. At t is equal to 0, theta is equal to 0. And at time t, the angle is theta between B and A. So theta will be equal to omega into t. So we can write magnetic flux BA is equal to B into A cos omega t. And if there are n turns in this coil, in the rectangular coil, there are n turns, then the total magnetic flux will be equal to n times this. So n into B into A cos omega t. This will be the magnetic flux passing through the coil when its subtend angle theta with the magnetic field. So we can write n is constant, number of turns, B is constant, A is constant. So we can put, this is constant, and we put it phi 0B, maximum flux. So phi 0B will be equal to NBA. So we can write phi B will be equal to phi 0B, which is the maximum flux, into cos omega t. So it is a function of time. Time change होगा, then क्या होगा? Phi B will change. Now we know that when the coil is rotating, then magnetic flux will change. Since omega is same, t will change, so phi B will change, or we can say phi B is a function of time. So according to the Faraday's law, when there is a change of flux, then induced EMF is produced. And from Lenz's law, we get the direction of induced current or induced EMF. The direction of induced EMF current is such that it will oppose the cause which has produced it. So if we use both Lenz's law as well as the Faraday's law, then EMF will be equal to minus d phi b bata t. So EMF is negative rate of change of magnetic flux with respect to time. So this will be equal to d phi b bata dt. So we put the value of b here. So it will be equal to NBA into d bata dt of cos omega t with the negative sign. Now the differences of cos omega t is equal to minus sin omega t into omega. So it will be equal to NBA omega and sin omega t. So EMF will be equal to, the induced EMF will be equal to NBA omega sin omega t. So here also we see that EMF is a function of time. Means EMF will change with respect to time. The magnetic flux also changes with respect to time. So magnetic flux as well as magnetic flux is function of time. EMF is also function of time. Both are function of time. Now here we can also say that n is constant, b is constant, a is constant, omega is constant. So we put it equal to E0, which is the maximum EMF. E0 will be equal to NBA omega. So what will be the EMF? So EMF we can write EMF will be equal to this will be equal to E0 sin omega t. So what will be the current? Current will be equal to, from Ohm's law, current is equal to EMF by resistance. R is the resistance of the coil, total resistance of the coil. Then the current, induced current will be equal to EMF bata. So I is equal to EMF is E0 sin omega t divided by R. So now E0 is fixed, R is fixed. So E0 bata I, we can put E0 bata I as a constant, and which is maximum current I0 is equal to E0 bata R. So we can write the induced current is equal to I is equal to I0 sin omega t. So current is also a function of time. So here we see that phi b function of time, and current is also function of time. So now how it changes? Now we know that EMF is equal to E0 sin omega t, current is I0 sin omega t, and magnetic flux is equal to phi 0 cos omega into t. So omega t, if the value of omega t is equal to 0, then if substitute the value here, 0, so cos 0 is equal to 1, so it is equal to E0. So it will be equal to phi 0b maximum initially. Then when the sin 0 is equal to 0, so EMF will be equal to 0, and here also sin 0 0. So when time t is equal to 0 means initially phi is equal to maximum, current is 0 and EMF is 0. So here the current here, so at t is equal to 0, EMF is E0 maximum, current is 0 and EMF is 0. So the value of EMF will be equal to 0, and the value of magnetic flux will be phi 0b at t is equal to 0. When omega t is equal to pi by 2, cos pi by 2 is equal to 0. So flux will be equal to 0. Current will be maximum I0, and EMF will be also maximum, because sin omega t is 1. So it is equal to 0. So when it is 90, then EMF is maximum. This curve will represent EMF, lower curve is current 0. So it will be equal to E0, and here this will be equal to I0. So when it is 90 means this is the NS, and when 90 means when it is 0, it is like this, and when it is 90, then it is like this. So here flux is 0 and the current and EMF are maximum. Then when it is pi, when it is rotated by 180 degree, then cos pi is equal to -1. So it will equal to minus phi 0b sin pi 0. So E 0 and I is equal to 0. Here. So at this point, when it is equal to pi, then the flux will be equal to minus phi 0b, and current is 0, EMF is 0. When it is equal to 3 pi by 2, this angle is 3 pi by 2. At 3 pi by 2, again 3 by 2. Then cos 3 pi by 2 is 0. So flux will be equal to 0. This represents the dotted flux is 0. And sin pi by 2 is equal to 3 pi by 2 is minus 1. So it is equal to minus E0. Current will be equal to minus I0. So here the current will be, we put it here, then this is minus I0 and this will be minus E0. And when it is 2 pi, then sin cos 2 pi is equal to 1. So it will be equal to phi 0 be cos 2 sin 2 pi 0. So it is 0, it is 0. Again here it is maximum and it will be equal to phi 0 b. So in this way, what we see? Here we see that EMF for half the cycle. This is half cycle. This is total. If you take the time period, then this is 0 to t and this is t half. For half time period, the EMF and current is positive, and the value of EMF and current is changing. It is going from minimum to maximum and then maximum to 0 as the angle increases. So here the value of EMF and current both are positive but variable. It will be maximum when the angle is pi by 2 and it will be increasing from 0 to pi by 2. It will be decreasing from pi by 2 to pi. Then after this will be the half cycle. In the next cycle, then it is being negative. So here it will be increasing, negatively increasing, and then when it is 3 pi by 2, then EMF is maximum minus E0 and current is maximum minus I0, and an angle increases from 3 pi to 2 pi, then the value of EMF and current is decreasing. So what we say here? Here say that it is for half cycle it is positive value, half cycle it is negative value. The value of current and EMF are not constant, they are variable. So we can say such type of current is alternating current. This current will be alternating current. Alternating current means the current whose value is alternately changing for plus to minus, then plus to minus until after the regular interval, and such type of current is known as the alternating current. So alternating current can be produced by rotating a coil or rectangle coil in the magnetic field. So by rotating, what will happen? The magnetic flux will change. So EMF will produce, and we apply the Lenz's law and we find the value of magnetic flux as well as the EMF and current, and we see that here the magnetic, when the magnetic flux is maximum, then current is 0. When current is maximum, then magnetic flux is 0. Here, when here the current is 0, EMF is 0 and flux is maximum, though it is in negative direction. So when the EMF and current are maximum, EMF is 0. When current and EMF are minimum, then flux is maximum. So here we see that the magnetic flux changes periodically, means after half cycle it will change. Similarly, the EMF also changes periodically. For the half cycle it will be positive, variable, and for next half cycle it is negative and variable. Similarly, the induced current also changes periodically. For first half it is positive and for next half it is true. So here we can also say one more thing, that EMF and current, they are in phase. In phase means when ये 90 ये भी 90 है, when 0 है ये भी 0 है, यहाँ भी 0 0 है. So यहाँ पर EMF and in phase means the phase difference will be equal to 0. So E0 and I0, E and I are in phase. Means phase difference phi will be equal to phase difference is equal to 0. Whereas phase difference between flux and current is 90. Here it is maximum, it is 0. Here it is 0. It is maximum. So 90 degree. 90 phase का होगा. So the phase difference between magnetic flux and EMF and I0 is 90. The phase difference between E and I0 is 0, or we can say they are in same phase. So this is the principle how to obtain alternating current, or in short we can say AC current. And AC current is denoted by this signal. Whereas DC current, which is not variable, that is given by this in battery. So here the value positive will always remain positive, negative will be always negative. Here positive and negative will change alternately and with the same frequency.